Let's see how do you integrate 1 over e raised to x minus 1. 99% of the students wouldn't be able to even start this integral because they don't even know the first step. I'll show you how do you exactly start and complete this integral step by step in this video. You start this integral by putting e raised to x is equal to u. So we'll do a u substitution here for e raised to x. The questions that students ask me is, can you even do u substitution? Because I don't see the derivative of e raised to x, which is e raised to x in the numerator. If the derivative is not present, what you essentially do is you first find the inverse of this function before converting this integral from the x world to the u world. Let's see exactly how would we do that. Since the derivative of e raised to x, which is e raised to x, is not present in the numerator, what you have to do is you take the inverse of this function. When I say inverse of this function, I mean you separate out x, or you find the value of x first and then differentiate this. Okay, so in order to find the value of x, I'll have to take ln on both the sides. So what you do is you take ln. So you write ln e raised to x is equal to ln of u. By the property of log, this x can come down, and therefore you would have x ln e is equal to ln u. Okay, remember that ln e is nothing but 1. So therefore you have x is equal to ln u. So this is called taking inverse of the function. Initially it was u in terms of x, or u in a function of x. You convert it in the form of x as a function of u. Again, why do we do this? Because the derivative of e raised to x, which is e raised to x, not present in the numerator, and we are still doing u substitution. Whenever you are still doing u substitution without the derivative being present, you take the inverse of the function and then take the derivative. Now let's take the derivative with respect to x on both the sides. So let's differentiate with respect to x. Actually, let's differentiate with respect to u. So differentiate with respect to u on both the sides. So derivative of x, or differentiation of x with respect to u, is dx by du, and differentiation of ln u with respect to u is 1 over u. Now, in order to convert that integral from the x world to the u world, we'll have to find the value of that dx. Okay, and from here, from this equation, I can say that dx is nothing but, you just multiply the du on the right hand side, is du divided by u. So that's the value of dx. So now let's convert the entire integral from the x world to the u world, and you would have, so you would have integral of 1 over, it was e raised to x minus 1, but e raised to x is nothing but u. So you can write u minus 1, and instead of dx, you can just write du divided by u. I hope that makes sense. Now, if you notice carefully, this integral is turning out to be an integral which you see in partial fractions a lot. So this will become 1 over essentially u times u minus 1 with respect to u. Now, in order to do the partial fractions, what you say is let 1 over u minus 1 is equal to a over u plus b over u minus 1. Why do we do partial fractions? Because the denominator is in terms of factors. Okay, so we can do the partial fractions here. Now let's simplify this. So just cross multiply over here. So we have a into u minus 1 plus b into u. Okay, on this side we have, and the denominator we have u times u minus 1, and over here I have 1 over u times u minus 1. This u times u minus 1 and u times u minus 1 will get cancelled. So essentially you will be left with over here 1 is equal to a times u minus 1 plus b times u. Now we need to find the value of a and b, and mostly it will be solved at that point. Now, in order to find the values of a and b, we just assume some values, some random values of u. So let's say, let's take u is equal to 1, because if we take u is equal to 1, this term will be 0. So let's assume first u is equal to 1. So if you take u is equal to 1, you have 1 is equal to a times 0, because 1 minus 1, plus b times 1. Okay, so therefore you get the value of b is equal to 1. I hope that makes sense for the value of b. In order to find the value of a, what you do is just put u is equal to 0, because that would make this term is equal to 0. So if you put u is equal to 0, you have 1 is equal to a times 0 minus 1 plus b times 0. Okay, so essentially that would give you 0 minus 1 is minus 1, so that would just give you a is equal to minus 1. I hope that makes sense. So now that we have the values of a and b, we can just substitute it over here. So essentially that integral will become, therefore we have integral of a over u. So a is minus 1, so we have minus 1 over u plus b over u minus 1. So b is 1, so 1 over u minus 1, and with respect to u. So now let's solve this integral. So actually it should be equal to over here. So now give this integral to both of these terms. So we have integral of minus 1 over u du plus we have integral of 1 over u minus 1 du. So minus is constant can be taken out of the integral. So we have minus. Now integral of 1 over u is nothing but ln u. I should say ln mod u to be specific. Ln mod u. Okay. Plus integral of 1 over u minus 1 is nothing but ln of u minus 1 plus let's add the constant of integration c. This is almost your final result. We can resubstitute the value of u. We know u was nothing but e raised to x. So this will become minus ln of e raised to x plus ln of e raised to x minus 1 plus let's add the constant of integration c, which is already there. If you want, we can apply the properties of the log over here to make it look cleaner. So it's log a minus log b. So this will be nothing but log of a minus b, or a divided by b, sorry. So this will be log of e raised to x minus 1 divided by e raised to x plus constant of integration c, and this is nothing but the final result of the integral that we are looking for. If you want to see more such videos on calculus, including integrals, differentiation and math in general, please do consider to like this video and subscribe to this channel. Also, I do post math and calculus content every single day. That's another reason to subscribe. I'll see you tomorrow.